Next, I'm going to give you a couple more examples of sketching graphs using transformations. I have two functions. The first one is 2 minus x plus 5 quantity squared. The second one is 2 times the square root of x plus 4 minus 3. If I ask you to graph either one of these functions, you're going to start out with a series of scratch graphs. You're going to use that final scratch graph to come up with the key values that you would put in to give me a final smooth graph. If I just ask you to sketch the graphs, you will give me the series of scratch graphs. So in either case, you do have to give me the series of scratch graphs, one without a final graph if I just say sketch. If I ask you to give me the graph following all rules provided in class, you'll give me the scratch graphs followed by the graph with all of the points. So I'm going to rewrite this in the form that we saw using the transformation lectures. And the way I would rewrite this is negative x plus 5 quantity squared plus 2. Just so that you can see that this shows the same form that I had before. Where this plus 5, because it happens before the function rule x squared is applied, is going to be a horizontal shift to the left. This is going to be a reflection across the x-axis, and this is going to be a vertical shift of 2. So to do my series of scratch graphs, first step is to make a graph of the parent function, which is y equals x squared, which is our memorized parabola. Then you follow the order of operations. If you were to put a number in for x, the first thing you would do would be add 5. So in this case, that causes a shift of the graph to the left 5. So I now have that parabola. Then we are going to reflect the graph across the x-axis. And my final step is I am going to shift that graph to vertically. And that would be my final scratch graph. If all I asked you was to sketch the graph, this would be your final graph. If I asked you to graph the function, you would now start putting in values to get the 5 points, the vertex, then 2 to the left and 2 to the right. For the second function, it was already written in that standard form. So our first thing we're going to do is we are going to graph the parent function, which is y equals the square root of x, which looks like that. Then we are going to shift the graph 4 to the left. Then we are going to stretch it, which means it shoots up faster because this number is greater than 1. And notice, I don't really care how much you shoot it up faster. I just need to see that there's a difference here. Because if I were actually to ask you to graph the function, you would start putting numbers into the function once we get done with our transformations. The final graph for this shift would be to shift the entire graph down 3. And this is my scratch graph. If I ask you just to sketch the graphs, there's your answer. Now for this one, I'm actually going to start putting numbers in so that we could actually get our values. So let me draw it a little more accurately here. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Y, arrow, X. So I already know what the first point I'm going to put into this function is. I'm going to put a negative 4 into the function, and I better get a negative 3 for the output. Negative 4 plus 4 is 0. Square root of 0 is 0. 0 times 2 is 0. 0 minus 3 is negative 3. So in fact, I do get negative 4, negative 3. Now I'm going to put the next number to the right, that's going to give me a perfect square, which would be negative 3. Negative 3 plus 1 plus 4 is 1. Square root of 1 is 1. 1 times 2 is 2. 2 minus 3 is negative 1. So at negative 3, I have negative 1. Now I'm going to put a 0 into the function. 0 plus 4 is 4. Square root of 4 is 2. 2 times 2 is 4. 4 minus 3 is 1. So I got 0, comma 1. And those are the 3 points that I need to make the smooth graph of that function.